Hey, welcome back to Pocket Roni. We're going to be doing substitution. You use substitution when you have two equations and two unknowns. Here is how you do substitution in words. The very first thing you do is you need to get one of your equations into y equals something, ... or x equals something, ... Sometimes I like to say y equals blah or x equals blah. The next thing you do is substitute the ... into the other equation. And the third step is solve for the variable that you have. The fourth thing is substitute your answer number 3 back into one of the original equations to solve for the other variable. Okay? Let's look at 14b, 7 through 9. 2x plus y equals -1 and y equals -3x. The first step is to get one of your equations into y equals ... or x equals ... In other words, y equals something or x equals something. You can see that we already have this in the form of y equals something. So you take our something or your ... and you substitute. We're saying y is -3x. So you take your y is something, take that something, and put it back in for y right here. So you take your 2x plus, now you substitute this information for y is -3x, into right there, equals -1. We don't need to write two signs here, so a positive and a negative. Adding a negative is the same thing as saying 2x minus 3x equals -1. Combine your x's. That would be -x equals -1. What coefficient is in front of here? It's a -1. You cannot leave a negative in front of a variable. So therefore we divide each side by -1. A negative divided by a negative is a positive. 1 divided by 1 is just 1. So x equals +1. So that was step 3 is what we did. We solved for the variable that we had, which was x. We eliminated y. We didn't have y here, so therefore we solved for x. Now our fourth step was to take this answer, substitute it back into one of the original equations to solve for y. Okay? I am going to take this, x equals 1, and put it in for x right there. I can put it into either equation. I'm going to put this in for x right there to solve for y. Y equals -3, and we said x equals 1. So -3 times 1 is -3. So y equals -3. So what we have done is we have found a coordinate. We can write it also as 1, -3 as a coordinate. And that is the point on the graph where these two lines will intersect. Okay, now we're looking at 14d, 4 through 6. Remember, the first step is to get one of your equations into y equals something or x equals something. Neither one of these is in that form, okay? So I'm going to get this one into the form of x equals something, which means I need to move my y to the other side. So if I subtract y to both sides, I have x equals -y minus 5. Now I have this one in the form of x equals something, or x equals ... or x equals blah. I can take my x equals something or x equals ... and since this is x is this, I need to plug it back in for x over here. Okay, all of this is x, so it needs to be substituted over here for x. So now we can say y minus 2, now we're plugging all of this in for x. I've written this so far, y minus 2. Minus 2 times x, I need to use parentheses, -y minus 5 equals 4. This was all of my where x went, okay? The main thing to be careful here is you distribute this -2 to everything. So this will be y, a negative times a negative is a positive, so it'll be plus 2y. A negative times a negative is a positive, so it'll be plus 10 equals 4. So now the third step was solve for the variable left. Our variable left is y, so I want to solve for y. Combine our y's together. 3y plus 10 equals 4. Move my 10 to the other side. 3y equals 4 minus 10 would be negative 6. Divide both sides by 3. Y equals negative 2. That's one solution. Now, what we do from there is step 4 was to take this answer and substitute it back into one of the original equations to solve for y. Okay? So, here's my original equations. There's equation 1. There's equation 2. So I'm going to take this and put it all the way back in right there for y. Okay? So that means that would be negative 2, because y is negative 2. Negative 2 plus x equals negative 5. I'm solving for x, so I need to add 2 to the other side. Watch your signs. X equals negative 5 plus 2, so x would be negative 3. So I have now found a coordinate. I can also write it as an ordered pair as a coordinate, negative 3, negative 2. That will be the point on the graph. If you graph both of those original equations, they would intersect at this point. Now we're looking at 14a10. Remember, the first step is to get one of your equations into y equals ... or x equals ... I can see that my second equation, we're going to call this equation 1, this one's equation 2. My second equation is in the form of y equals ... So therefore I want to take my ... put it back in for y in the first equation. So now substituting in, we still have our 2x, leave the subtraction sign, minus 3, that stays, times y. Y is x plus 3, so put that in parentheses, equals negative 4. The key thing again here is to distribute this negative 3 to everything. Distribute that negative. 2x, negative times a positive, negative 3x. A negative times a positive, negative 9. Now we're just solving for x. Combine your x's. 2x minus 3x would be a negative 1x. Minus 9. Add your 9 to the other side to combine whole numbers. Negative 1x equals positive 5. I do not want to leave my negative in front of the x. Okay, so divide by negative 1. A positive divided by a negative is a negative, and 5 divided by 1 is just 5. So x equals negative 5. Now step 3, that was step 3, solving for that variable. Step 4, take this value, x equals negative 5, and plug it back into one of your original equations. I think it would be easier to plug it back into equation 2, so I'm going to take this and plug it back in for x. Right there. So I can say y equals, plugging negative 5 in right there, keep your signs, plus 3. And negative 5 plus 3 is negative 2. I can also write that as a coordinate, x value first, negative 5, negative 2, and that is a coordinate on a graph where those two lines would intersect.